Hi friends, today we are going to discuss about a new topic, that is radioactivity. Okay, so before going to the radioactivity, we are going to discuss what are the factors affecting the stability of a nucleus. There are two factors affecting the stability of a nucleus. The first one is neutron-proton ratio. So neutron-proton ratio. If neutron-proton ratio is equal to 1, neutron-proton ratio is equal to 1, the nucleus is stable. Nucleus is stable. Otherwise, the nucleus is unstable. If neutron-proton ratio, N by P ratio is equal to 1, that nucleus is stable. Otherwise, it becomes unstable. So this is one factor affecting the stability of a nucleus. Second factors affecting the binding the stability of a nucleus. The second factors affecting the stability of a nucleus is binding energy per nucleons. If the binding energy per nucleon is greater, Be by A, the binding energy per nucleon is greater, it is stable. It is stable. If the binding energy per nucleon is less, it will be unstable. So there are two factors affecting the stability of a nucleus. One is neutron-proton ratio and binding energy per nucleon. If a neutron-proton ratio is equal to 1, that nucleus is stable. If binding energy per nucleon is greater, that value is greater, the nucleus is stable. If binding energy per nucleon is less, the nucleus is unstable. So the nucleus is unstable if neutron-proton ratio is not equal to 1. So the nucleus need to attain, or nucleus need to acquire the stability. For acquiring the stability, the nucleus itself will do an arrangement to reach the stability. So due to that, some radiation will be emitted, like alpha, beta and gamma radiation. So the process will be very spontaneous process. So due to the emission of radiation from a nucleus of an element, due to that the nucleus will become to stability or reach to stability. So that is known as radioactivity. That is a spontaneous disintegration of a nucleus of an atom by the emission of certain radiation like alpha, beta and gamma. That is called radioactivity. Okay, so today now we are going to discuss about what is alpha decay, beta decay and gamma decay. Now we are going to discuss about alpha decay. So alpha decay means is the emission of alpha particle. It is the emission of alpha particle from a radioactive nucleus is called alpha decay. So we know that an alpha particle is equivalent to a helium nucleus, that is represented by 2He4. So that means it have a mass number 4 and atomic number 2. Mass number 4 and atomic number 2. So that means when from a nucleus an alpha particle is decay, alpha particle is emit, we get a new nucleus. It having atomic number is decreased by 2 and mass number is decreased by 4. So this is a nucleus. When alpha particle is decay from this nucleus, we get a new nucleus that having mass number decreased by 4 and atomic number is decreased by 2. Okay, so this is the representation of an alpha decay of an element, and here Q is the emission of energy. It is the energy emitted during this process. For example, uranium 92 238 so undergo alpha decay. If the uranium 238 92, so 92 is the atomic number and 238 is the mass number, so undergo an alpha decay. So we get a new nucleus, that is thorium. Thorium have mass number 234 and atomic number become 90, and an alpha particle will be emitted from the nucleus, and also energy will be emitted. So this is one of the example for alpha decay. So uranium 238 undergo alpha decay, we get a thorium and an alpha. This is represent the alpha particle. and here this is the atomic number. So compared to the parent nucleus, the atomic number is decreased by 2, and compared to the parent nucleus, here the mass number is reduced by 4. So this is the alpha decay. So now we are going to discuss about beta decay. Beta decay. So beta decay means it is a emission of an electron from a nucleus. That is called beta decay. So beta is equivalent to an electron. So when a beta particle is emitted from a nucleus, the atomic number is increased by 1. But there is no change in the mass number. For example, XZA is a representation of an element. Suppose a beta particle is emitted, we get a new nucleus, it having atomic number is increased by 1. But there is no change in the mass number, and this is a beta particle will be emitted from a nucleus. So this is the beta decay. So we can classify this beta decay into two types, one beta plus decay and beta minus decay. We can classify beta decay into two types, one is beta plus decay and another one is beta minus decay. In beta minus decay, the atomic number is increased by 1. How it is increasing means, in a nucleus, a neutron is changes to proton and electron and an antineutrino. Neutron changes to proton, electron and antineutrino. Because of that, the atomic number is increased by 1. And in the case of beta plus decay, inside the nucleus, a proton is changes to a neutron plus a positron plus a neutrino. In the case of beta minus decay, inside the nucleus, a proton is changes to neutron, positron and neutrino. So because of that, the atomic number is decreased by 1. So we discussed about beta decay. There are two types of beta decay, beta plus decay and beta minus decay. And in the case of beta minus decay, the atomic number is increased by 1 because inside the nucleus, a neutron changes to proton, electron and antineutrino. So because of that, the atomic number is increased by 1, but there is no change in their mass number. But in the case of beta plus decay, inside the nucleus, a proton is changes to neutron, positron and neutrino. Because of that, the atomic number is decreased by 1. Now we are going to discuss about gamma decay. So gamma decay is a spontaneous emission of gamma ray photon from a nucleus is called gamma decay. It is an emission of gamma ray photon from a nucleus is called gamma decay. When a gamma decay takes place from a nucleus, the mass number and atomic number has not changed. That means there is no change in mass number and atomic number. This takes place when a nucleus is make a transition from high energy state to the low energy state. So here we can see a nucleus of an element XZA. This is an excited state. This make a transition from the excited state to lower state. The energy will be emitted. That energy is called gamma decay. So due to the emission of gamma decay, it comes to the stability. So this phenomena, this decay is called gamma decay.